Order DVD at www.fromheretoandramada.com.
The work that Hutchins has been doing, he has Tesla coils, he has Van de Graaff, and he has, very frankly, static electricity generators. Notice that data doesn't have to make sense.
Right.
Data just has to be truthful.
The truth.
That's right.
It's more important than proving Einstein right or wrong.
Okay, now his data showed everything from a chocolate milkshake snaking toward the top of his room, to bowling balls floating in the air. To I have all his data, and I've been following it. I am a senior scientist from Lockhead Martin. I have been a senior research engineer for Howard Hughes, Texas Instruments. Nevertheless, we've been working for some time now in order to determine where the next energy levels are going to come from. Now by that I mean we aren't talking about wind or solar or even atomic. We have other formats of energy that we've theoretically proven that are available. Not only that, but there have been significant developments, and many times the things that we look at and call UFOs are really some of the developments that we've been involved with.
That Lockheed has been involved with?
That were open. Looks pretty good to us down.
So are these some of the UFOs we're seeing you believe are ours, that are United States military?
Well, Area 51 is literally where the majority of the things that we call the black program were developed, and many times sightings would occur directly associated with them.
So you had
as I conducted tests, every now and then nature would not give us what we wanted, but it gave us something else.
Something else.
And I would sweep it under the rug because it didn't match theory.
So do you
and after a while I said, that is not honest. That is not proper. You must record the data properly. And indeed, once you record the data, then you start modifying the theory. Einstein's work is only a slight modification of Newton's work. But we do understand that Newton's work has, well, Newton's work, for example, Newton says anything that's in motion tends to remain in motion, right? Okay, so I have something, and I'm taking it around counterclockwise, and see it, and what Newton said is true. It just wants to go around and around and around and around and around. This particular thing is called a celt. It is not. It's clear plastic. There's nothing in it. Okay, now I'm going to take it around clockwise. It says, no, I don't want to do that. It's just like my children. I will do it my own way.
How did it go the other way?
Precisely. A Newton's law.
Is that because of the rotation of the planet, or?
Well,
Can I try that?
You may. In fact, first of all, send it around counterclockwise.
Okay. And this is called a cell?
It is celt. C-E-L-T.
What's in it? Okay, there we go.
Nothing's in it. It's plastic. Okay, now take it around clockwise.
Okay.
And it says no, and it goes back the same number of turns you said.
Oh, I've never seen anything like that.
Now go out stronger. I know. See, I'm looking for the exception to the rule. You have to, if you can use language, you really need to convert it into mathematics.
Yep.
And calculate what your theory would say that it would do.
My theory is, like I've looked at, and on that CD I sent you, in bubble chambers,
yes,
if you look at, they have a lead sheet in this particular photograph. Super high frequency gammas strike the lead sheet and through the photoelectric effect give off electron-anti-electron pairs. And there's two sets of pairs. And the electron has a longer wavelength and the anti-electron positron has a shorter wavelength, which means there's a differential between the electron and anti-electron pairs, which means one is stronger than the other if you convert it through a Planck formula or even Einstein formula.
Well, see, you're,
And that means one of the clockwise and anti-clockwise would the differential between them would be one is stronger in mass energy equivalent. The other, like for example,
well, take that with you, and when you get together with your friends that agree with you, have them do the math, and I would like a copy of the math.
there's
back.
a differential.
A lot of people are doing nothing more than getting huge quantities of mass and see if they can get a gravity wave to cause things to move. Well, that isn't what we're talking about at all. So I wondered if gravity could be related to its cousin magnetism. And so I found that when I take two magnets together, I have some neodymiums around here that I'm actually afraid of.
They're so strong.
They can danger you. But anyhow, you take a magnet, you go to put them together, and they go clunk, right? But you take one of them, move it around, and all of a sudden it doesn't want to go together.
The repulsive.
So I got I ordered one at $5,000 a piece, with a 1/4-inch hole through between both of them, and I put a brass bolt and I tightened them down, forcing them together, and then I put them together in a thing that looks kind of like a rock. Okay, and then I got another one that didn't have magnets in it. And Galileo, in all his endeavors, he went up to the Leaning Tower of Pisa
And dropped the.
and he dropped a big rock and a small rock. And his buddy down at the bottom kept telling him that the large rock and the small rock arrived at the same time.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? That proves that Mr. Galileo was correct in his findings.
Well, I went up to in the Lockheed Building 501 by the side of escalators and elevators.
Oh wow!
And I got 9 guys that were not educated and didn't have pre opinions on anything, and I dropped my 2 rocks. And I said, what I would like you to do is, I told them what I'd like you to do is I would like you to take whichever one arrives first, get it in your hand, and when I come down the elevator, hand it to me. Now, they looked identical, except for...
So, and nobody knew what was inside?
No, absolutely not. All the 9 times that I tested it, it's as though the one with the opposing magnet field extending out 3 feet on each side. I actually measured how
big the field is.
How big the field was, and on each side of one rock, I had a total of 6 feet. At any rate, the other rock arrived first.
Which one arrived first?
The one that had no magnetic field in it.
So you were able to cancel out gravity to a certain degree. You were able to cancel,
precisely,
reduce the mass gravity effect.
Precisely.
By opposing fields.
Isn't that nice? You bet. And got 9 signatures and I always skip. You
did that at Lockheed. What year was this?
Oh, at least 8 years ago.